Today, we're diving into the world of one of nature's most feared creatures. We're going to uncover the truth behind a very common, and maybe even life-saving piece of advice about scorpions.
You've heard this line before, right? It's a classic, delivered with so much confidence by Indiana Jones himself. And honestly, it's become this widely accepted rule of thumb. If you run into a big, nasty-looking scorpion, you're probably safer than if you see a tiny one.
But is that actually true? I mean, is Hollywood's favorite archaeologist really a reliable source for scorpion safety tips? That's the huge question we're tackling today. We're going to see what happens when this little piece of pop culture wisdom gets put under a serious scientific microscope.
All right, let's get into it. To find our answer, we're leaving the movie set behind and heading straight for the laboratory, where a group of researchers decided to formally test this rule of thumb once and for all.
So, a big study, back in 2022, did exactly that. Scientists got data on 36 different kinds of scorpion species. They measured everything, their total body length, the shape of their pincers, and they compared all of that against how potent their venom was.
Now, before we get to the results, we got to understand how scientists actually measure how dangerous venom is. The gold standard is something called LD50. It stands for lethal dose 50%. Basically, it's how much venom it takes to be lethal to half of a test group. And here's the key thing to remember. A lower LD50 score means the venom is more potent because it takes less of it to be deadly. You can think of it like a golf score for venom. The lower your number, the more dangerous you are.
Okay, so with that in mind, the researchers crunched all the numbers from those 36 species. The big question, did Indiana Jones get it right?
And the answer is, yep, he nailed it. The study found a really clear, statistically significant connection. On average, smaller scorpions do have more potent venom, those lower LD50 scores we just talked about. And they found something else too. Scorpions with those skinny, weaker-looking pincers also packed a much more powerful punch.
And this right here illustrates the two extremes perfectly. Over on the left, you've got something like the rock scorpion. It's large, with these big, powerful crushing pincers, but its venom is relatively low potency. Then on the right, you have the infamous deathstalker. It's smaller, with these thin, almost delicate-looking pincers, but its venom is one of the most potent in the entire world. The visual rule totally holds up.
So this isn't just some random coincidence. It's the result of a really powerful evolutionary pressure. It all comes down to a classic biological trade-off. So why would evolution make a scorpion choose between having big claws and having deadly venom?
Well, think about a scorpion's toolkit, right? For hunting its prey and for defending itself, it's got two main weapons. Its pincers, for grabbing and crushing, and its stinger, for injecting that venom.
But here's the catch. Developing and maintaining both of those things at peak level, I'm talking powerful muscular pincers and a complex, super potent venom, is incredibly expensive for the scorpion's body. It just takes a ton of energy. So over millions of years, evolution has basically pushed scorpion species to specialize. You kind of have to pick a lane.
And this lays out the two paths perfectly. On one side, you have brawn. These are the species that invest all their energy into growing big bodies and massive crushing pincers. They can just physically overpower their prey. They don't need a super toxic sting. Then you have the other path, poison. These guys stay smaller and pour all their energy into cooking up this complex, fast-acting, and incredibly potent venom to do all the heavy lifting for them.
Now, this isn't just a fascinating little bit of biology. Understanding this rule has some serious, real-world consequences because scorpion stings are actually a major global health crisis.
Yeah, the medical community has a name for it, scorpionism. It refers to the whole range of symptoms that are caused by the venom from a scorpion sting. And believe me, it is a huge public health problem in many parts of the world. How big of a problem? Well, it's estimated that about 1.2 million scorpion stings happen every single year around the world. And honestly, because so many of these happen in rural areas and go unreported, the real number is probably way, way higher.
And out of those million-plus stings, it's estimated that about 3,250 of them result in death every year. This is why knowing how to quickly assess the risk, just by looking at the size of the scorpion and its pincers, is a genuinely life-saving piece of information.
So when a sting does happen, doctors have a way to classify the symptoms to figure out how bad it is. As you can see, it's broken down into 3 classes. Class I is all local stuff, what you'd expect right at the sting site. Intense pain, swelling, that kind of thing. But with more potent venom, it can move up to Class 2, which involves more systemic issues. But the real danger zone is Class 3. This is where you see severe, life-threatening symptoms hitting the whole body. We're talking respiratory failure, cardiovascular collapse, even neurological damage like paralysis. This chart really drives home how fast a seemingly small sting can become a full-blown life-or-death emergency.
But the story of scorpion venom doesn't just end with danger and death. In this really fascinating twist, the very same thing that makes it so deadly also holds some incredible promise for us.
So you have to ask the question, is this incredibly complex chemical cocktail really only a weapon? Or could it be something more?
And the answer is a resounding no. Scientists are now looking at scorpion venom not just as a toxin, but as a complex biochemical library. It's like a treasure trove of unique molecules that have been perfected over millions of years of evolution. And a lot of these compounds have unbelievable therapeutic potential.
I mean, look at this. Researchers are actively studying parts of scorpion venom for a huge range of medical uses. Some of these peptides have been shown to target and kill cancer cells while leaving healthy cells alone. Others are powerful antimicrobials and antifungals, and some are even being looked at as possible treatments for autoimmune diseases. It turns out the killer might also be a cure.
It really makes you wonder, doesn't it? That simple rule we started with, the bigger the better, is rooted in this deep evolutionary trade-off. But that very same pressure has created a substance that is both a deadly weapon and, maybe, a source of life-saving medicine. It leaves us with one last fascinating question. What other cures are hiding out there in plain sight, inside the world's deadliest creatures?